Well, hi, good morning. Welcome to my shop here. It's December 19th today, and I've got something under that towel. I thought I got to make a little bit more of a dramatic opening here today, so this is my dramatic opening. Are you ready for this? What the heck is this? Okay, it's a radio. I think we can figure that out pretty quick. What the heck is going on? What is this? So what I plan to do today with this guy is simply inspect him very, very carefully and kind of come to grips with what it is and what's in it, and most importantly, what am I going to do with this guy? So Ultradyne Super Het. Isn't that something? So at a glance, you would think this is a TRF radio, a tuned frequency radio with no intermediate frequency. But look what it says right on it, Ultradyne. So I'm looking at this essentially for the first time with you. Yeah, I've had it here for about a week and I've glanced at it, but I really haven't looked closely at it. So that's a shocker. I had no idea. Super heterodyne set. Mixer. It says grid leak. Volume with an I above it or a 1. It's got a oh, this is marking the top of the control. That's what those things are. Volume. Oscillator. There's something wrong with how that's spelled. Oscillator. The LS would be loudspeaker. And then it's got a meter here. Appears to be connected essentially to the output. Rectifier type. Volts AC, DC. So maybe there's a rectifier built into this meter. It's another control. Grid leak control. Okay, that's the front of it. Does everything turn? Or look at this control. Look at that. That's pretty spiffy. Make sure everything can turn. This one's got the same deal. This fine adjustment. And this is probably a big rheostat that controls the heat going to the heaters of the tube, because that was how volume control was done in the earliest days. They just don't let the tubes run as hot as they could. Okay, I'm going to turn this around now. We're going to take a look from the back here. Oh. Wow, this is a heavy guy. Now, where'd this come from? This is owned by an individual here in Aurelia, where I live. He's a bit of a radio collector and general unusual guy. He picked this up, he said, at a flea market, I think he mentioned. And my guess is he's done nothing with it except had it, and maybe he's had it for quite a long time. So what he's asked me to do is, hey, put it on my bench and let's see what happens. My guess is that this was inside of a regular big coffin style radio, 1920s radio, and somebody removed everything from the radio and remounted it all just as it was in the radio onto this plexiglass pieces here. Why they would do that exactly? Wow, that raises a pretty interesting question. Why would somebody do this? Because the coffin boxes, when they're in good shape, you know, they're part of the radio. And got a nut that's fallen off here. Put that on. We don't want any stress in this thing, or the last thing I want to have happen is something to crack or the like. Well, where do you start with something like this? I guess we'll start at the antenna. How do we do that? Eventually I'll get out the close-up camera, we'll take a closer look, but right now we're taking a long view of this thing. So antenna and ground, and they're heading, that was my head hitting the microphone, by the way, they're heading into this coil. So this is probably the antenna coil. And I think one of the things we can kind of realize here, when you see the size of this coil and you see the size of this coil, that one of the things that was going on in the world of radio development was learning how to make these coils smaller and smaller. You know, so in a regular radio now, they're just a little coil the size of my finger. not a big thing like this. Can you tell that it's got a woven style where the wires are woven around? And that's so the wires are crossing at angles. Like I said, wires. They're not doing this. They're doing this. And that can reduce capacitance, I think. Interwinding capacitance or something like that. What's this knob for? Why am I taking it out? It won't come out. So I believe that's an adjustment then. I don't think it's holding this in place. Something else is holding it. That's some kind of adjustment. Well, we'll look at it with the close-up camera. And we have a rather odd-looking arrangement here. Again, the close-up camera will help with this, but something missing right here, right between here. Why this funny shape here? Pretty odd. Now that's connected to the grid leak through this control, and wow. Okay, good. I don't know what that's doing. Again, we'll look more closely at it. Let's look at the tubes at this point. Since they're sitting here, so they're mounted on, rubbery. Rubbery, I guess is the right word. Rubbery mounts, because these tubes tend to be very microphonic, and so any vibration transmitted, through the table or the radio is going to get in the tubes. You're going to hear it. This looks like a big rectifier tube here. So does this one. Why in heaven's name would they do that? And what would they even be rectifying in here? Where do you apply it? So the power is applied here. Here's B minus. This is 135 here. So this is probably B plus at 135. It's 85, 45 volts. A minus, A plus. C minus, B minus, B minus. They don't have B plus on here. They have B minus written on it. So I 6 of one, half dozen the other, I guess. B minus, B plus, C minus. Where's the C plus? Where's the C plus go? Okay, you can see all these long wires basically, but look, they're all in contact here. So some need to really look at these wires carefully. Now, what about the rest of these tubes? So these all look like very typical tubes. I can't think of a number. 201? 01? Okay, now I'm going to pull it out because it's in there pretty good. We'll leave it in. So I'm not ready to fool around with them. Oh, something missing. There's room for another tube here. What I assume is a tube. That's too bad. It's not like I'm going to pull out a schematic for this, I'm pretty sure. Although if this is actually a radio, a known radio, just remounted on the plexiglass, then I should be able to find a schematic for it. And there's nothing terribly complicated about these radios. Now, I see there's a trimmer capacitor here and here and here and here. That's a little bit unusual. I'm going to guess that these are transformers, and they're RF transformers. No. Yeah, RF transformers running at the IF frequency. And what would that be? What would the IF frequency be in a radio like this? So then, which one of these is the oscillator? The oscillator. Okay, so this is the oscillator control here. It's right adjacent to this coil arrangement here. So we can guess this is the oscillator, part of the oscillator circuit. Looks like it's got two sets of windings, and one of them is coming apart here. The wires are just not really coming apart, but loosened up would be the way to put that. So what's the action here? This doesn't make a lot of sense to me. You have identical, 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 different, identical, you know. Which one is not like the rest? This guy. He's supposed to be down here. I'm going to guess my buddy who gave me this has done nothing at all with it. So if I phoned him up and said, hey, what's with this tube? He'd say, that's why it's on your bench. If we look down inside this coil here, can you see that there's another coil inside it? And I think I can rotate it. Okay, that's an alignment adjustment right there. A lot of frayed wire here. Now usually these things, these kinds of things, they have a control, and you can turn that from the operator's position, you know, up on the panel here, but there's no control for it. So that means there's a total of 3 coils here. Maybe 1, 2, and then the third one is inside. Maybe that's an alignment thing you do to set up the oscillator to the correct frequency. And you do it once, and then you don't have to do it again. So there's a rheostat up here. It's also, you can't adjust it from the front. Like, can you get under here and do it? Nope. So you have to come in here with a tool or something, or turn it with your hand. It's right at the limit. It's right at one limit. So I'm not sure what that's all about. Maybe that's rough volume, refined volume. Maybe that sets the minimum heater current or something. Who knows? I don't know. So going back to these trimmers then, each of these trimmers' job is to tune this transformer. But you know what? These there's only one. If this is a transformer, it's got 2 coils, and each one needs to be tuned. Only one tuning thing. Lots of ifs. Well, this is a capacitor here. Capacitor here. Where's the detection done? Where is the detection done? So maybe that's what this tube's doing. Or maybe this is driving the speaker. It seems to be involved with this rheostat. Let's follow the speaker back. Yeah, that'll answer some things. Here's the output. Right here. So this is a capacitor here. The things attached to this terminal don't have a nut tightening them down. They're just on here. These 2 guys are are audio transformers. So these would be RF transformers, and these would be audio transformers. They're quite a distinct difference, isn't there? So you can see there's an interest here from a radio manufacturing or design point of view to do as much with RF because it's smaller than to try to do things with AF. Why are there 2? Because there must be audio. I take a wild guess. The audio is detected and amplified at audio frequencies at least once. So this tube's missing. This is probably the audio output tube here. There's not a lot of tubes to select from back at this time. You know, it was like 4 tubes in the world. One of them doing almost everything. The OA1, something I can't remember. So this has a switch built into it. When you plug in your speakers, why would you bother with this switch? It has all these wires coming to it. What's all that? Why so much? Okay, that's kind of the long distance tour. Now we're going to repeat that. Take a closer look at things. Provided I can find where the camera is. And also, there it is. Just let me get the dialog box ready for that camera in case I don't like where it's focused. I'm not focusing bit. Okay, here we go. Let's start at the speaker end where we ended last time. Speaker end. So here's the oh, what was that? Start by looking at this. Now, why would they bother putting this here? The patent numbers. That's a really good question. AC DC, so it can take an AC signal and produce the reading on it. Plus AC. So I guess if you have DC, you can stick it into bypass the rectifier. But if you have AC, you feed it in a way that it must encounter a rectifier inside. And the calibration would be pretty questionable about something like this. H. Really pretty potent soldering done on this. Okay, next thing, let's look at these capacitors. Just take a scan of them and just see if there's anything. So that's interesting. You can adjust. I guess you can adjust the tension really easily with these knurled knobs. If it's too loose, I mean, it's going to fall, right? Feels fine though. The plates are perfectly parallel. Good shape. Anything shorting? Looks okay. Now we'll take a look at this coil here. So now you can see the loose wires. There's a wire disappearing inside. Can't find the other end. There's one there. Down there. Might be hidden right under here. Well, yeah, there it is. So two separate coils here with a start and an end we can find on both of them. Then inside is there really a coil on that thing? Yeah. Oh, two coils or one wound a very, very special way. And there's this wire. Now, how did this get so frayed, or did they do this on purpose? This may have been done on purpose to make the wire very, very flexible. It's very strange looking. Either it was done on purpose or a mouse got in here. That's odd. That's very odd. But maybe I don't know. I don't know how that would improve the flexibility, frankly. I think that's a mousing. How come only there? So, lots of corrosion on it. Look at that. What is all that? Just dirt, maybe? More knurled connectors, as if you're being invited to attach these and unattach them. That actually looks loose. Loose. Okay, yeah, one more capacitor here. Same, they look not quite identical. So the plates do not look equal. There's a gap there. Maybe they're going to come into contact. Something not quite right there. Let's see what happens. Yeah, I think there's one there that could be in contact. See if we can hear it. No. No, they don't seem to be shorted. It's kind of odd that. Let me just move one or two of these plates back towards where they should be, and everything's perfectly fine here. There's a spring in there. Why would you bother with a spring? This thing has a huge amount of stick pressure, like friction. It's not going anywhere. It's possible that's a way of connecting the rotating part to the non-rotating part and not utilizing the actual pivot point as an electrical contact. So that's what that could be, just to improve the ground, basically. Quite likely that's what that is. That's a basic problem in all capacitors. This rotating part has to be connected to something. How are they going to do it? There's often slipping contacts, but this is using a spring wound, springy thing. Spring thing. Is the same thing over here? I didn't see it. Oh yeah, same thing over here. Okay. So, okay, that's it for those. Let's look at this, since we're right here. So this is pretty rusted, isn't it? Doesn't that look rusty? Like it's steel? So this could be plated steel, and the steel plating, the plating is kind of gone on it. It could be. Something like that. I can't imagine it'd be bare steel. So, you can expect to have trouble with this thing, that's for sure. Oh, there's some writing. Bearing in mind, all these things we're looking at were high-tech devices. So companies would proudly put their name on them there. I can't really read that. AMSCO? AMSCO? There's a tube number. Look at that. Made in Canada. Tube number 26. A 26. That's not what I was expecting. A 26. Hold on, are these all 26s? This one's okay. National Union Radio Tubes. Never heard of them. National NUR. Never. This tube test. Okay. It tested again. There's a date you would write there. What is it? It's somebody's Hunt's radio. Whose radio service is it? Jim's radio. No. Bert's. Hey Bert. Hey Bert. Where are you? Hemlock. He's on Hemlock. National Union. He's on Hemlock. No, he's on Cole Street. 844 Cole Street. Hemlock? He's from a town called Hemlock. Where is that? SF. I don't know what that is. SF. I don't know. That's kind of interesting, though, isn't it? So these stickers, these are historical. The reason this sticker's on this tube is because they had a hard time selling these tubes to people. Because they buy a bunch of tubes for their really cool radio, which used a lot of tubes, just like this thing. They bring them home and plug them in, and within days, one of them would be dead. What? They go back, hey, I'm not buying any more tubes from you because I bought 6 and one went dead in 2 days. And that's why the retailer will say, well, listen, my tubes have a sticker on them. And my name is on the sticker, so I know I sold you that tube. And I wrote the date when I tested it right up here. And I know when I sold it and when I tested it. And you're bringing it back to me, I'm going to test it again. You test it, oh, you're right, it's dead. Here's another tube for free. See ya. Or, I expect 5 months out of my tubes, and I'm getting 2 months. I said, okay, I'll sell you a new tube, and I'll deduct the loss of the first tube from the price of the second tube, so you don't pay too much. Because this is where the money was, selling these tubes, for sure. Well, I don't know that for sure, actually, but there's a lot of money in selling tubes. These tubes were not very reliable. So that's the whole deal. The sticker is there to help sell the tube. Now, of course, by 1931, you won't find any of these stickers anymore because the tubes have become so reliable, nobody was really panicky. Let's see if there's more stickers on any of these tubes. I don't think so. I think I would have spotted one. Now, I want to go back to the tube number. So this one's got, somebody has penned on 26. Okay, and this one, we never did see a number on it. We know who sold it, but we don't know what it is. That's crazy. Did I just Is it just blaring right at me and I missed it? Wouldn't he write it on here somewhere? Somebody could pull the sticker off, stick it on another tube and fool you. No, I don't see a number. This was the one we saw was 26. That's the first one that tipped me off to this whole deal. That's a 26. Does it look, it looks inked on though, doesn't it? Doesn't look professional. Like a manufacturer's thing. Now what's this one? This is the one I think is a number 80. Oh. 5Z3. To do a little research on these guys. Okay, so the other one that's a double. This one, this big one here, is this the 80? Is there an 80? There must be an 80 in here. They gotta rectify. They gotta get DC in here somehow. Well, I have to pull the tube out. I think it's a little bit difficult to look at. What if I look at it right through the front here? Do I see a number? So unnumbered tubes is definitely a challenge. I mean, I don't even know. Is this tube in the right socket? I don't even know. How am I supposed to know this? To go on the assumption that it's in the right socket because that's where it is. I don't know if it's the right tube, the right socket. Not yet, anyway. How about this last guy? Is he another 26? I'm not sure I've ever had a 26. And he's got no number. Well, I am doing this to, you know, identify all the challenges and trying to bring this guy back. Pretty dirty too. Like, what happened to this thing? There's some kind of sand, like dirt explosion occurred near it or something. Wow. Oh, here, look at that. Here we are. Let's read this. It's the Westinghouse Microsensitive Radiotron number 26. It's scratched. It's got, well, what did he do? He scratched out old, so it's supposed to be new. I got news for you. It's old. Tested. Oh, here we are. October 20th, 1939. Was that tube in this radio? Was this radio on this plexiglass? No, it wasn't on the plexiglass in 1939. Full of 26s. Interesting stuff. Okay. Next thing we're taking a close look at are all the transformers, I think. Well, let's start out here at the antenna again. I don't think there's too much to see here. It's just an antenna terminal. So here's that coil. There you can see how the wires are woven. You're trying to arrange it so it's not, so the wire that a wire is next to is not paralleled with it. You can see that there's a couple there that look paralleled. Or to reduce the parallelism in here as much as possible. Atchison. Steinite. Steinite? Kansas. From Kansas. I'm afraid to say you're not in Kansas anymore. Some connections here, a lot of rusty stuff. Thumb screw connections. Yeah. Okay, now what about this gizmo out here? Let's look at the front first, just to remind what it looked like out here. Grid leak. Grid leak. So this is basically the detector here. Let's take a good look at what is happening here. So this is the control coming in from the front. I'm going to turn the control, which is going up and down on that screw a little bit, just a little bit. So it looks like a metal rod, you know, coming from the front. You can see my hand there. It reaches this wooden piece. And the wooden piece is just... How is this affecting anything at all? I don't... wow, okay. So you screw a piece of wood onto a threaded shaft. Okay, so looking a little further now, you can see the this piece of wood and the threaded shaft and the nut there are reaching a piece of material which is non-conductive. This brown looks like a plank, but it's just a little tiny thing. So is there a chance that this threaded shaft, you can just see disappearing in the wood, is being moved closer and farther from this metal piece, which is in fact grounded to the chassis? There's no chassis. There's no grounding out here. There's nothing. It's just floating out here on a piece of plexiglass. There's no nothing. There's no electrical. So how does moving a piece of wood, what is this? Maybe it affects the timbre of the sound. That's my joke for the day. It's another threaded shaft right over here. Well, he hasn't got anybody hooked up to him. Okay, so let's just go a little further now. On the other side of the insulated thing is what looks like a rubber. Doesn't it look like rubber? Doesn't feel like rubber. Feels like a hard material. Yeah, my nail didn't catch it at all. It's very hard material. Then you have this carefully constructed screw-down clamp, which looks like it has a lock washer in there. So you screw this down. Oh, there's some words there. What's that say? CH, that's the manufacturing code, I think, or something like that. So what's the deal with this? So this is something going through, and is it that the wood has come loose, and you're really supposed to be turning that whole piece, which would turn this whole piece? Well, what good would that be? Can you even move this? You can't turn this, can you? Oh yeah, you can turn it. So how's that up? So that's probably what's happened then. This thing has. So that means if I turn the front knob and oh, the knob has a limit. So you can only go, once around basically. Well, I think what we can conclude that whatever this is, it's bunged up and needs attention of some sort. It kind of strikes me it's a capacitor, but it says grid leak. So a grid leak has a resistor and a capacitor acting in combination. So this maybe this is a variable capacitor. You squeeze more down on it here. I mean, it's not working properly, but if you could tighten it, you'd squeeze more down. Maybe that would vary some capacitance through here. So it would have to have 2 plates and 2 electrodes. So one of them would obviously be this thing. This whole bracket, this would all be part of it because it's just hooked up to it. And that plate there with the slots cut in it would be the other plate, and then what? That doesn't make a lot of sense. This is metal in behind here, and in behind is nothing. Okay, that's a strange thing, some foreign technology come from another planet or something. I don't know what it is. Okay, so you may be familiar with this stuff and you're telling me what it is, and I just haven't figured out. Well, look at that. this makes contact here. Look at this. So this clip on the left is applying pressure on that thing that I think is pushing through against this. For what reason would... And then there's that other threaded shaft with nothing on it. And the connection down below, that's hard to spot from up here because it's kind of hidden from view all the time. Connection to what? So these two guys are suspiciously positioned. What are they doing? So it's stuck. I guess it's just clamping this. And so there's a tang down here with nothing on it. Looks like there's some solder, but did something come off there? There's a link here. This is kind of like a link. Is it split at the back? It is. It's like a link you could unscrew. Don't know why you would. So grid leak involves a resistor, a relatively high value resistor. Back in the day it was tough to make effective grid leak resistors, tough to make high resistance resistors. So they were using different techniques, like even carbonized paper inside a glass tube, and the carbonized paper has a certain resistance, very high resistance. I don't see a grid leak in here anywhere. I'm just looking around now while I'm talking. I'm not looking for the grid leak. It seems to be, it would probably go here, between here. But grid leak resistors, I'll have to grab one. They're made to snap into something. Look at this complicated little deal here. What were they trying to achieve here? Like, so they have this bar coming off, riveted here. So riveted here suggests to me that this is nothing more than something to hold things in place. It's not actually part of the electrical stuff. So it's coming around here, and then it has this arrangement here that you can change the angles on almost everything to get to here. And there, that's that same spot where I suspect you're supposed to have a grid leak resistor, but I don't see how it would go in there unless the clipping part is missing. No grid leak resistor. I haven't seen one anywhere. Have I just overlooked it? So another capacitor here. Yeah, just right out in the open. The screws go right through it. There's something written on it there, 109 or something. Okay. So this whole apparatus here is a real mystery to me. Just what is going on with it. Can't say I've ever seen anything quite like that. Let me just give it a longer view of it here. So what was somebody thinking when they came up with this? Well, it definitely says grid leak on the front, so it's got to be controlling a grid leak arrangement. Yeah. Wires coming out of this coil don't attach to it. This attached to it here. What's it going to up in there? Uh-oh. So I see a blob of solder here. It would appear to have been desoldered. Looks like there's another solder. It looks like this is off. Huh. So you get broken connections that you can't see. Here it comes up to the capacitor. And this clipping thing with this, it's almost like a brake. And this is just totally out of range of, like, it's nowhere near being tight. How could it have, maybe it was never done right. So, okay, so if this is able to turn the wheel, so what? What's this doing? What are the chances that this is the resistor? This weird arrangement. So if it were a resistor, I guess it would be a resistor between here. So electricity to get from here to here, this away, has to follow this bracket, get onto this thing, get into this rubber piece, or whatever material this is, and then come back this way. And that would be it. Let's put the ohm meter on here. This is a weird thing. Here's my ohm meter. Goodness knows what this is all about. Let's get it here. Just clip on there. Well, that shows an open circuit between these 2 points. I'll put my fingers there. You can. Oh, yeah. Hang on. Let's just improve that. So that's my fingers. 2.2 mega ohms. Open circuit. Open circuit through this. I mean, it looks like a piece of rubber, right? I mean, let's turn it by hand and see what happens. Oh. Just my finger on it? I'm not really. I must be changing the friction of it. Let's turn it. There's a slot cut in it right here. Every time I touch it, touch some other part. Oh. Really? How would that, how would just, you know, my other hand's here. How does that happen? Just touching that. Touching it very lightly. How am I doing that? Well, it's just getting more and more mysterious what that material really is. So I'm going to guess this clip is about applying pressure. Could it be a variable resistor? Just not a very good one. Yeah, it just seems to be a lot of contact sort of problems in here. I mean, it could be all through here. Let's move this up closer. No, that effect is gone. Oh no. Oh, I touched this. I touched this. My finger is bridging something there. Yeah, that's what that is. You know, we're on the 200 mega ohm scale, so. But it wasn't bridging it before. It was a momentary bridging there. Hey, let's touch it with something else, like a piece of wood. Well, isn't that curious? How does that work? The stick does nothing. What is going on there? The magic of an old radio. And just barely touching this. I'm not putting any real mechanical force into it. Well, I don't know what to make of that effect. I've never seen anything quite like that. Touching something that appears to be non-conductive in the first place. I'm going to guess variable resistor here. This might be one of the earliest attempts to make a variable resistor. You know, when you think about it, when you look inside a potentiometer, modern potentiometer, what do you see? You see a black trace and a slider going over it. What do you see here? You see a black trace and a slider going over it. This might be one of the earliest attempts to make a variable resistor. Aside from, you know, the wound wire type. The reason is you can't wind a wire type and achieve, you know, 2 or 3 million ohms. That's what you have to get to. So this is how they've done it. In that case, that's a thing of beauty. That goes from being a really weird thing to a thing of beauty. A real piece of history there. What else could it be? So grid leak adjustment has to do, it's kind of like a biasing issue. And so you're biasing the, usually the output tube. It could be, no, it could be biasing the detector tube. This is hooked up right to this tube. So what do we get here? We get, there's no rectifier in here because this radio is not fed with AC at any point except for the signal on the antenna. It's got battery power, so there's no rectifier in here. So what are these two tubes? Oh yeah, 5Z3. 5Z3, that's right. I remember we already figured that one out. 5Z3. Sure, sounds like a rectifier. The Z is a rectifier, I think. Anytime you get that high alphabetic letters, X, Y, or Z, on a tube of this vintage, it's a rectifier tube. I think that's how that works. And this one just looks like a 26. So that's not the one I want. This is the one I want. Oh, just going to come right out. Ooh, doesn't that sound horrendous. There's a C. A nice letter C there. Is this the getter? Yeah, that'd be the getter pot. You can see the little pot in there. I don't know if you can see it or not. Yeah, there's like a flat plate with a little pot. Probably the getter. It's kind of splashed around the inside. It's splashed on the inside of the tube structure too. Boom! Blew it out there. What is it though? C. Is that the only thing I can see? Is the C? I can only see the C on the top. Oh boy. It's really not good. What about down here? It's a Marconi. Look at the pins. That's by far the worst. By far the worst I've ever seen on a tube. Okay, so we're getting towards the end of assessing this thing. This, I would say, is the hobbyist special. I'm not really a hobbyist as such. I'm really interested in taking a radio that's in rough shape and bringing it back to life. This definitely qualifies in the rough shape department. But there could be so many things here. My familiarity with this vintage of radio is limited to about 5 or 6, 7 that I've worked on. 1 or 2 I really goofed around at length once with. Got audio transformers. These are known for having defects in them, in these radios. They may not even be any good. No schematic. I'd have to draw up a schematic. This has been smashed in here. This is smashed in, I think. Looks that way to me. These ones are all on the outside. This one's smashed in. It'd be shorting these out. Yeah, that's smashed in there. Let's unsmash it. How did it ever get smashed in there like that? Wow, really smashed in. Let's get him out where he should be. I think like this. There, fix the radio. She's ready to work. So this would also be very early examples of trimmers. They look exactly like modern trimmers, the way they're built. It's got a nice little cup there to catch your screwdriver and direct you into the screw, sort of. So there's definitely an alignment issue with all these. You do have a capacitor here. Look at this capacitor. This capacitor, look at this. Look at this. How did I miss this? This capacitor has the clips for the grid leak resistor. Hang on, let me just see if I can find one really quick. And I find them. Okay, hold on just a moment longer because I know exactly where there's one. Few here. So these are examples of grid leak resistors. These are high-tech guys from the day. These were hard to make. The makers of them were quite proud. They would. I'm going to show you this under the close-up camera. They would definitely boast with a nice-looking sticker. It's the Kelford. It's tested. 1/10 megohm. That's 100,000 ohms resistance. Now look inside. You can see it looks like brassy looking metal on either end. Now what's right in the middle here? We can't really make out what they're doing exactly. There's something in there. So we don't know how they've done the resistive element in this one. Oh, not going to see much in here, and the label is shot on it, so we don't even know what. I don't know what's going on with this. And didn't I bring 3? Where did I thought I brought 3 in here? Yeah, I rolled way over here. There's number 3. Well, this one you can look right inside. So you know what I'm seeing? I'm seeing a carbonized paper clamped at either end, and then metal leads coming out to the caps. So that's a piece of paper. That's a carbonized. Oh, it looks like cardboard. Carbonized something in there. That's what I think I'm seeing. And that's how they achieved. They made a resistance unit. Davin radio. The sign of merit. The sign of merit. Look how he spelled sign, though. The sign of merit. Why would he? Well, it's a G. No. How do you spell sign? Newark, New Jersey. Isn't sign S-I-G-N? Sign S-I-G-N? He's got it in quotes there. Maybe it's some kind of a play on the idea of a sine, cosine, that kind of stuff. I don't know. Okay, so here's the deal about these. They go into a clip like this. There it is. They should be at the audio end of the radio. This is the audio end. This grid leak thing is up at the wrong end of the radio. So what exactly this is grid leaking for? Maybe the very first amplifier tube? Not clear to me what's going on up here. this is the grid leak resistor, and you would literally change this resistor. You might have 2 or 3. And if your radio was really distorted, maybe from a strong signal, you could try a different grid leak resistor and it kind of rebalance or rebias the tube a little bit. Maybe clear up the distortion, give you a better sound. So these were mysterious little guys who affected the sound big time. Maybe they weren't so mysterious. Okay, what else can we discover here? At the last minute I've discovered this. And we looked at the tube label here, which was kind of fun. I think that's really it. So what's this all amount to? In terms of powering this thing up, I'm sure I could pull off something here in my shop to provide 135, 85, and 45 volts. I think I can pull that off. There's a missing tube. We don't know what it is. There's not too many tubes to choose from. It's out here. It's the last tube heading for the audio. My guess, it's another 26, but it might not be. 26 is surprising. I thought these were older. They're not. We saw something that said, yeah, the sticker on here talking about 1939. It's a little hard to believe that this radio would be in regular, not on plexiglass, but back in its original cabinet, would be in regular use all the way up to 1939. Because, oh, I'll take that back. I was going to say because super headsets came in. This is a super headset. I wonder if this one was really distinguished as a very early super headset, and that's why somebody took the time to remount it on here, because there's some fame to this radio. And what radio is it? There's not a hint. Not a hint. I mean, these coils aren't that unusual looking. This nothing unusual about this. Nothing unusual about these. Well, maybe you know. Maybe you know what radio this actually is. I'll do some research and see if I can't find it. It's possible. It's just a standard radio. It's not something somebody cobbled together. I really believe this has come out of a box. It's a big box, eh? This would be in a big box. Yeah, big one. One of the bigger ones. And an oscillator adjustment. And then what's this other adjustment then? So the oscillator is the tuning adjustment. The other must be some front end tuning sort of stuff. It's up here at the front end. It's tied in with not really. It's tied in with one of these coils down at the bottom there. All these tubes need to be tested. For all I know, only 2 of them are working. Who knows? Maybe it's a whole load of dead tubes. Yeah, this is quite a project here. This might be something I'd pick away at, spend a couple days on it and then set it aside again. And then somewhere later drag it out and spend another couple days on it or something like that. How hopeful am I to make this work? Not very hopeful, frankly. I really have my doubts. I mean, there could be, show-stopping problems in here, especially with these 2 guys. All the tubes may be shot. I'm not sure if somebody wants to stick, 9 26 tubes in here and risk them. Okay, so that's it for this. Tomorrow I will have another radio in here, and we'll start again on another European radio, similar to the last 2 I did. Very great big one, and work away at that. And in the meantime, I'll spend my time thinking and doing a little bit of research on this for the day when it does come in here for some work. So I'll give you one last look at the front here. What a beast. I have to guess this was done for some school. I don't know. $95. Oscillator, I'm sure it's spelled wrong. Okay, thanks a lot for watching, and I'll see you on the next video. Hey, it's exactly 1 hour. How do you like that?